In this lesson, we're going to draw force diagrams. Your objective is to be able to draw a force diagram showing the forces acting on an object. To recap what you've learned, forces are represented by arrows. The length of the arrow represents the magnitude or the size or how strong the force is. And depending where the arrow is pointing, it will tell us the direction. So it could be pointing left or right, up or down, or maybe north, south, east, or west, for example. To begin, what is a force diagram? This is something for you to note on your notes. A force diagram is a model of the individual forces that act on an object. So it's not the actual forces, it's simply a drawing or a representation of what's happening. If you look at the blue and green arrows pointing up and down, you'll see that they're the same length, so the forces are balanced. They're also in opposite direction, something required for forces to be balanced. For up and down, there is no net force. When we go left and right, the shorter arrow pointing to the left means it is a weaker force to the left, and the longer arrow pointing to the right means you have a stronger force to the right. So, since up and down are balanced, and then left and right you have a stronger force to the right, our net force is to the right. So whatever object this is will begin to accelerate to the right. How to make a force diagram. So these are the steps. We'll walk you through it with this block of cheese, and then we'll try some examples. First, identify the forces. This cheese is resting on a table. The force of gravity is pulling it down. The normal force is pushing back up from the table, right? We don't usually think of this force pushing back up from the table. However, if only gravity was pulling it down, then the cheese would be falling down. But the table is also applying a force. 2. Draw a dot or a square. You'll see force diagrams with both. You draw a dot to represent the cheese. We are only representing one object at a time, the forces that are acting on it. Okay, step 3, you draw your arrows. Arrows point away from the dot, and the lengths should be relative to each other. This means if they are equal length, the arrows should be equal. If one force is stronger, that arrow should be longer. If one force is weaker, that arrow should be shorter. Finally, label all the forces. In this case, N is for the normal force pushing up, and G is for gravity pulling down on the cheese. Types of force diagrams. So you can have multiple forces acting on an object. In this first example, you have 2 forces acting on an object. You might have 3 forces, or you might have 4 forces acting on an object. Let's do some practice, and then you'll be ready to try on your own. Example number 1 is a book resting on a table. The book is resting, so it's not moving. So let's draw our dot. We have gravity pulling it down. Since it's not moving, the forces must be balanced. So my arrow from the normal force pushing up from the table must be about equal. And those look to be about equal. All right, so we have gravity and normal force. 2. A car traveling at a constant speed to the right. When you have either no motion or a constant motion, your forces will be balanced. So if we draw our dot for our car, we have the forward direction of the car. We're going to call that an applied force due to the gas pushing, or the gas engine pushing the car forward. And we also have a balanced force of F for friction, and they must be the same length because the car is not accelerating or speeding up, and it's not slowing down. Example 3. In here, we have a car accelerating specifically to decrease its speed. So it is moving to the right. However, the applied force is going to be shorter, so that motion to the right is actually going to be weaker than the force of friction. That would be friction between the car's wheels and the road, as well as friction between the brakes and the tires, or the brakes and the wheels. And that will get the car to slow down. Eventually it will come to a stop and the forces will balance out again. Now that you've seen some examples, go ahead to the next activity and see if you can try this on your own.